Example 21. The number of floors in a row of a particular design of wallpaper is known to follow a Poisson distribution with mean 0.2. Calculate the probability that Part 1. In each of two rows selected at random, there are no floors. Part 2. In a random sample of 5 rows, there will be a total of exactly 2 floors. Let us define the random variable. Let x be the random variable, the number of floors in a row of a particular design of wallpaper. So x follows a Poisson distribution with lambda as 0.2. Part 1. We are talking about 2 rows. So we need to define a new random variable, which is x1 plus x2 follows a Poisson distribution of 0.4, which comes from 2 times 0.2. Since there are no floors, it means the probability of x1 plus x2 is equals to 0. And using a GC and using the command Poisson PDF, where it is equal, keying in the lambda as 0.4, x as 0, you end up with 0.670. Part 2. We are now talking about 5 rows. So we need to define a new random variable, x1 plus x2 plus x3 plus x4 plus x5, which follows a Poisson distribution 1, where 1 comes from 5 times 0.2. And since we are talking about 2 floors, it means probability of x1 plus x2 plus x3 plus x4 plus x5 is equals to 2. And using a GC and calling for Poisson PDF, with lambda as 1 and x as 2, you get the answer as 0.184. Example 22. An advertising display contains a large number of light bulbs which are continually being switched on and off. Individual lights fail at random times, and each day the display is inspected and any failed lights are replaced. The number of lights that fail in any one-day period has a Poisson distribution with mean 2.2. A. Find the probability that at least 4 lights will need to be replaced on a particular day. B. Find the probability that in a period of 7 days, at least 4 lights need to be replaced on at least 2 days. C. Calculate the least number of consecutive days after which the probability of at least 1 light having to be replaced exceeds 0.9999. Let us define the random variable. Let x be the random variable, the number of lights that fail in a 1-day period. So x follows a Poisson 2.2. Part A. Since the probability is asking for at least 4 lights, it means probability of x more than equals to 4. And since GC is not able to work out for greater, we need to convert it into less than, which is 1 minus probability of x less than equals to 3. And using the GC, by keying in 1 minus Poisson CDF 2.2 and 3, you get the answer as 0.1806. And through to 3 significant figures is 0.181. Part B. Take note of Part B. It is related to Part A. So we need to define another new random variable. Let y be the random variable, the number of days out of 7 where at least 4 lights need to be replaced. And in this B, we know that y now follows a binomial distribution with n as 7 days, and the probability of replacement is 0.1806, which comes from Part 1. The required probability is probability of y more than equals to 2. And again, GC does not work out, cannot work for more than, you need to convert it into less than. And keying in the GC as 1 minus binom CDF with n as 7, probability of 0.1806, and x as 1, you end up with 0.369. Now, part C, to calculate the least number, okay, where n is unknown. Okay, so let us define a new random variable. W be the random variable, the number of lights that fail and are replaced in n consecutive days. So now W follows a Poisson distribution with a new lambda as 2.2n. The question is asking for the probability of at least one light having to be replaced exceeding 0.9999. It means probability of W more than or equals to 1 greater than 0.9999. And since GC cannot work the greater sign, you need to convert it as 1 minus probability of W equals to 0, which is greater than 0.999. And by simplifying, you end up with probability of W equals to 0, which is less than 0.0001. With that in mind, we need to key into the GC Y1 as Poisson CDF with the lambda as 2.2x and 0. And calling out the table of values as shown in the screenshot on the right, we need to look out for the value such that it is slightly the first number to be less than 0.0001, which corresponds to 5, where we can write down when n is equals to 4, probability of x equals to 0 is 0.00015, and when n equals to 5, the probability of x equals to 0 is 0.000017, and when n equals to 6, we have probability of x equals to 0, which is 0.000019. But we need to take note that this is the first value where the probability is 0.000017, which is less than 0.0001, and corresponding to that, it is 5. Therefore, using the GC from the table, the least number of consecutive days is 5.